Good morning, everyone. Welcome to Tech Field Day Extra. My name is Ashish Shah. I'm a VP of Product Management at Avi Networks. Avi Networks is a modern load balancing and application services company. And over the period of next 1 hour or so, I'll spend about 10 to 15 minutes talking about what the product is, the product architecture, the use cases, and then we'll do a live demo or a set of demos. Okay. Let's get started. Avi's been around for about 6 years now. We are headquartered in Bay Area, California, Santa Clara, California, but we have offices worldwide, including Europe, Asia, and we've a brand new office in Australia. What we've built is a next generation platform, a software platform that does load balancing, web application firewall, and elastic service mesh for Kubernetes and OpenShift and other container solutions. It's a universal solution for both traditional use cases, on-prem load balancing, replacing legacy load balancers, as well as more modern use cases, public cloud, private cloud, containers, and so on. It's delivered both as a self-service or self-managed, as well as a SaaS form factor. We'll talk about that. As a company, we've been growing rapidly, seeing significant growth. We're also a strategic partner with Cisco. Not only we are on Cisco's price list as a Solutions Plus partner, but Cisco's also invested in Avi. And our focus primarily is around global 2,000 companies around the world. Top verticals that we have been successful at are financial services, large technology companies, service providers, primarily their IT department, retailers, and so on. Over half of the large banks throughout the world use Avi today, replacing the legacy hardware vendors. Some of the public references include Adobe, which is, as you know, one of the largest digital companies where they've deployed us both on-prem as well as in Azure. Mobile payment-to-payment companies, large retailers, they're all using Avi today. And the primary reason why they've chosen to use Avi is around our architecture, around our built-in automation capabilities, around elasticity. So that's what we'll talk about. As a platform, as a product, it's a single product. It's called Avi Vantage Platform. It's a software-only solution that delivers all the layer 4 to layer 7 services. So load balancing, web application firewall, and service mesh. And the control plane, we'll talk about the architecture, can be delivered as a SaaS or customers can deploy their own control plane. Okay, that's about the introduction. We'll go right into the product architecture. Most of you are familiar with load balancers, right? Appliances, monolithic, big, maybe virtual appliances, which are nothing but hardware appliances put in a VM form factor, for example, right? What Avi did was we disrupted the architecture. So our competitive advantage is not around a feature here or a better widget there. It's rooted in the fundamental product architecture. And so we have separated the control plane from data plane. So that's the first thing that we did. You might have heard about this in other SDN solutions, right? Controller, elastic data plane. Well, we did the same thing applied to layer 4 to layer 7 services. And today, so far as we know, we're the only one doing that in the load balancing space. So there are two components. There are two software components to our architecture. The Avi controller, control plane, and the Avi service engine, the data plane. Both are software. The control plane is the brain of the system. That can be, again, spun up by the customer in their environments, on-prem or cloud, or it's also offered as a SaaS service. This is the brain of the system. So this is the single REST API endpoint. This is where all the configuration is done. This is where all the policy resides. This is where all the decisions are made. Okay? REST API is the only way to talk to the product. The UI and the CL are built on top of REST APIs. Every object is REST addressable. And the data plane, it's an elastic data plane. Service engines, they are stateless. So talking about the cattle versus pet analogy, they're cattle. You never log into them directly. The controller manages the life cycle. So the controller spins them up, spins them down, scales them out, scales them in, manage the HA. You configure your VIPs, virtual services on the controller. The controller decides, do I need extra capacity, spin up another VM or a container or a bare metal, convert into a load balancer, provision the VIP. If it needs additional capacity, scales out. Needs less capacity, scales back in. Okay? Because they're software, they can run anywhere. You give it a bare metal server, it becomes a load balancer. It can run as a VM on ESXi, a KVM, Hyper-V, and so on. It can run as a Docker container, more likely as a Kubernetes pod, running in Kubernetes, OpenShift, again, on-prem or in public cloud. In public cloud, again, it can run as a VM in AWS, Google, Azure, IBM Cloud, Oracle Cloud, and so on, all centrally managed by the Avi controller. In addition to doing load balancing or the proxy services, these service engines collect tons of telemetry data because, frankly speaking, the load balancers are the most strategic in terms of data plane location. They have application level visibility, and every application packet is going through that. So they collect this telemetry data, push it up to the controller. The controller not only uses that information for making automated changes, but also presents a nice dashboard. We'll see that in the demo. And this architecture is what allows us to do that because all the analytics gets collected and centralized at the controller level. By the way, the controller is also an HA, active, 3-node cluster, or 5 or 7. Intelligent, we talked about the telemetry data. And then finally, automation. And there are 2 parts to automation. There are 2 parts, and I actually have a slide on that one. The first part of automation is infrastructure automation. So the controller talks to the ecosystem environment. It talks to vCenter or OpenStack or Kube APIs or AWS or Azure for orchestrating the service engine. So when you configure, let's say in a vCenter environment and you configure a VIP, the controller would talk to vCenter to spin up a VM, talk to vCenter to put them in the right port groups, connect the front and the back end, download the policy in the service engine, and starts receiving traffic. Same thing happens in AWS, or same thing happens in Kubernetes. So this is, if you want to call it a southbound automation, infrastructure automation. The second piece of automation is the northbound automation, which is through the REST API. As I said earlier, REST API is the only way to talk to the product, and we have built not only UI or CLIs on top of it, but also Ansible playbooks, Terraform templates, Go and Python SDKs, integration with Splunk or other tools, right? And so this is the built-in automation in the product. Let me pause here. Any questions on the product architecture? I'll go back to the previous slide and ask any questions on the product architecture. Yeah. Well, I typically get a couple of questions here that I'll say if you had similar questions. What's the difference between this and a virtual appliance from, let's say, F5 or Citrix? They're also software, right?
Control and data plane, yeah.
Exactly. Thank you. It's the architecture, right? Because with the legacy appliances, with the software appliances, you still have to manage each appliance separately. There are multiple touch points, multiple control planes, multiple policy repositories. So the capacity management, you have to manually decide, should I place the VIP on this pair of active standby HA pair or this pair of active standby appliances? And so that's the fundamental difference. Here, by the way, these service engines can run active. And you can ask, well, how does single VIP run on multiple? We'll talk about that as well. But these can all run as an active, as a pool of resources. So if one of them dies, the controller automatically moves the VIPs around to the remaining service engines while it's bringing up another one. So you're not wasting
like
any capacity.
Cast.
Yes, BGP, RHI-based Anycast.
So effectively, the controller is not involved in the control plane. It's just the orchestration configuration management system.
It's actually both control plane and orchestration management system.
So what control plane function does it do?
So in terms of the control plane, deciding, so part of those are orchestration functions as well, but it's deciding where to place the VIP and then talking to vCenter or talking to AWS to be able to spin up a VM. So it's unlike BGP routing, there is no protocol level control plane. Agreed. Yeah. Yes. Okay. This control plane is not a protocol level control plane.
Which is good.
Yes.
It means that the controller can die and the things still work.
That's exactly right. We call it headless operation, where so it's a 3-node controller, quorum 2 out of 3. But if all 3 were dead, no problem. The service engines work just fine. In fact, they can fail over as well independently by doing self-election and while another controller is coming
Some
up.
intelligence still at the data plane.
in terms of like election capability.
Well, effectively, they're running control plane between the service engines.
For the HA. So what happens is
to keep alive stuff like
exactly. They're running keep alive. So the HA is managed two ways. Service engines are doing HA to each other, as well as the controller is doing HA to each.
So BGP
keep alive.
RHI you said, right?
Sorry.
BGP RHI you said.
From the service engine.
Injection.
So for example, if you're in a BGP environment, then to advertise the VIP, you do BGP RHI, right? And so do active 3 CMP. There are customers who don't have BGP running in their environment. So we just do just ARP-based traffic attraction. And in that case also, we can do active by having one of the service engine attract all the traffic and punting it to secondary or tertiary. That works very well when you are CPU bound, SSL TPS, for example, but not PPS bound. Mm-hmm. So the ideal design is BGP-based. That's what our recommendation is. We can scale N-way, whatever the router supports. The same architecture works in Azure or a public cloud environment, where you can do eCMP from the previous node. And we had a customer in public cloud doing 64-way eCMP in public cloud.
If the customer don't know BGP?
If the customers don't know, it's optional. Then it's just to do ARP response. You just respond to ARP. So only one service engine will have the VIP. And I think I have a slide somewhere I can show you where
either the customer invests into good people or the customer invests into magic. Their decision.
So here is a way. So here is one way, right? So if there was no BGP, then the middle service engine, let's say, is a primary. Assuming you're running active for a single VIP. The central load balancer, the service engine will attract the traffic. It'll serve part of the traffic, terminate TCP, SSL, TLS at HTTP, and serve the load balancer as a load balancer. But it'll rewrite at the MAC level part of the traffic to the other service engines who will proxy.
So it is like, let's say, 3 nodes here, and all of them replaying for the ARP?
No, only one.
Only one is replaying. One owns the control plane?
One owns the VIP.
GIBP, I think, like Cisco.
One owns VIP.
One owns VIP? So
yes.
Not 3 of them?
No, if you do BGP, all 3. In this case, no BGP, only one owns the VIP.
It's not like GIBP.
Yeah.
Not 3 data plane here.
No, you have 3 data planes, but one owns the VIP.
Standby.
And then you have layer 2 tunnel, effectively.
Yes.
Pushing some data to the other 2.
Correct.
The data is coming to the first one because it owns the VIP.
Okay.
And it says, I'm busy. Here, have some work.
That's right, Ivan.
Ivan is killing me. So basically, traffic comes, the data plane is coming to, let's say, node first.
Yes.
And then it is deciding, okay, let me send to another guy because, I am busy.
Yes.
And then to another one, layer 2 tunneling.
Layer 2 rewrite, MAC packet rewrite.
Yeah. Okay. MAC rewrite.
Yeah, MAC rewrite. So here, in this case, right, he gets the traffic, he serves part of that and responds with, does the load balancing function. Part of it is rewritten through MAC, through this guy, who then terminates TCP, TLS, HTTP, does the load balancing. The return traffic actually goes out straight.
Because they do source net.
That's right. We do source netting. That's right. So this is a non-BGP environment. A BGP environment, this doesn't apply. The router up front is doing eCMP, and it's actually much more efficient.
Okay, so in BGP environment, how do you handle rehashing?
Great question. Consistent hash, and during the failure or transition period. Yeah. So great question. So those we handle those by tunneling those to the right service engines. The state is shared of who owns the hash, who owns that state. Actually, I take it back. It's not shared, but if I get a packet that I don't own the state for because it was rehashed, then I advertise it and saying, does anybody have a state? Whoever has it then starts handling it and then goes from there. And this typically works because most of the connections are short-lived in the web application.
Yeah, so eventually it will even out.
Exactly. And this has happened all the time. Not all the time, but this has happened in the
customer environment. So you're using some sort of multicast to say, well, this is not for me. Who wants to have it?
I don't know. It's not a multicast at the level of the IP multicast, but yes, it's
no, layer 2 multicast.
Yeah, it's actually, I think it's just the IP unicast to all the service engines.
So in layer 2 case then,
yes.
say traffic hits to load balancer 1, then it's sending to some of the traffic to the load balancer 2, but since you are doing source net, so the traffic needs to go back to load balancer.
No, the traffic source net is here, so traffic goes back here, and then he responds directly. So what happens is when this service engine will use the VIP as the source IP. So as long as your network doesn't do MAC learning, you're okay. If network is doing MAC learning, then you're not okay. In that case, it has to go back to the primary and then go out. So there are cases, especially in public cloud environment, where in some OpenStack, if you have, or in ACI, for example, you have to disable MAC learning. Otherwise, the upstream network will think, oh, I'm getting the VIP IP as a source IP, but I'm seeing 3 different MACs, right? So either you disable MAC learning, or in those cases, the return traffic has to be tunneled back here and then go out. Correct.
Well,
so,
effectively, it's not MAC learning, it's ARP binding, gleaning from
yes,
the packets.
ARP binding, yes. Yeah. Thank you, yes.
Will we cover the MAC move, let's say VM mobility case?
VM mobility case, yes. Yes, it's basically MAC is learned again, but we don't recommend, like vMotion, we don't recommend doing vMotion with Avi. It's just instant kill it.
No, they don't care, because they are above that. vMotion is a layer 2 event. They are above layer 2. They just use layer 2, so who cares?
So in BGP case?
Oh, that's different.
Yeah?
Yeah.
What you will do with this sequence number and lots of things actually?
In BGP case, you need layer 2 connectivity to the upstream router. So if you move the Avi VM, you need VLAN extension to wherever you move the Avi VLAN, because it has a BGP session with the upstream router, which means you need layer 2 adjacency to the upstream router.
And it needs to inform the upstream router?
No, because the upstream router is a router.
You're doing RHI.
It has an ARP cache. It takes the destination MAC address. It sends the packet out. Who cares? The packet magically lands in the moved Avi appliance. That's the magic of vSphere.
So we actually don't recommend, by the way, in just
yeah, don't do that.
Instead, if you want to get rid of, just kill the VM. Like that intelligence is built in Avi. So we have some customers says we don't have control over vMotion. So we have tested it. We qualified. There is a small transition, a few seconds of downtime because all the VM is moving. But in an active environment, that's not an issue.
Just a quick question to that.
Yes.
We have talked a lot about the networking connectivity. I want to know the resource pooling. So you have here also containers.
Yes.
What if you run out of capacity? Can you dynamically spun up additional containers, or how's it work?
Yes. So great question. So that's the auto scaling piece. Right? So in container environment, in public cloud environment, or even in VMware environment, as long as the backend system supports autoscaling. So there are 2 types of autoscaling involved. Autoscaling Avi service engines, which is of course supported. So when you configure a new VIP, if the controller decides that I don't have enough capacity, it spins up another VM or a container. But also in many cases, it knows that application instances are running out of capacity. It can actually add application instances like autoscaling group in AWS or ScaleSet in Azure or Kubernetes pods in Kubernetes, yes. So it can autoscale itself, the data plane, and autoscale the backend applications.
So if somebody is sending you funky request and the buffer is getting busy, you just scale out. Yeah?
That's right. That's one of the real reasons why this horizontal scaling architecture works very well for WAF environment or even DDoS. You can create policies saying don't go crazy and create 100 instances. You can say this tenant should only allow to be create 10 instances, and this tenant maybe 4 instances. So you can do full multi-tenancy and decide how you want to control autoscaling. But that's exactly right. And that's one of the advantages that we have with WAF, because WAF, anybody's WAF, it's compute intensive.
Yes.
Right? So as the traffic grows, your idea is to grow horizontally.
And if they send very, let's say, advanced things to your WAF, will consume some compute, yeah, so...
Yes, of course, it's all compute. We use, but you had a question, Vivan, before I go...
Yeah, just, you will touch licensing, right?
Yes, we'll talk about it in just a minute.
Yeah, you're still bandwidth-based.
No.
No, okay.
We have compute, so a great question. So before I answer that, let me answer about performance, and then that's tied to the licensing. A common other question we get is, don't you need ASICs or hardware for high performance?
No.
Thank you.
No, we have programmers.
Yes, it's a myth, actually. Intel x86 has come a long way into performance. So I'll give you some numbers. Actually, I had a slide on that as well. I was not planning to present, but here it is. So the smallest unit of a service engine data plane is 1 vCPU, 1 core. Let's call it, forget hyperthreading, 1 core. That can do about 5 gig of raw throughput, L4 level, about 3 gig of L7 throughput, and a gig to gig and a half of encrypted SSL throughput per core.
That's reasonable.
Right? And full bulk crypto. And 2,500 new handshakes, assuming elliptical.
RSA?
1,000 RSA.
Okay.
1,000 RSA, 2,500 ECC, right? And if you have blended weighted average, right? But this scales horizontally. So if you have 2 cores, it's 2x. On a 48-core box, we have done over 100,000 SSL TPS, new handshakes, right? On one $5,000 or $8,000 commodity server, you can do 100,000 SSL TPS. You have to buy a large appliance for that from 5. And it scales linearly or horizontally. This is scale up, this is scale out, right? So we have done hundreds of thousands to even million SSL TPS. In fact, I have another slide coming up. This was done in a public cloud. Public cloud, 1 million SSL TPS for a single VIP. And we did the demo, we have on our website, the whole video, growing from 0 to 1 million TPS in about 8 minutes. By, I think it was a 40-way ECMP. And then scaling back in, right? That's the power of software and architecture, right? Where you don't need appliances. And what the customers like about this is they can do, so if I go back to my earlier slide, they can do per application and per tenant load balancing. So instead of putting large appliances in a shared services environment, put smaller set of VMs or containers per tenant or even per app, and separate the failure domain, have a separate scale-out domain, have basically isolation at the data plane level and control plane level with multi-tenancy.
I have just a quick question for you. Does it make for you a big difference what kind of processors under beneath? Do you have some special code that is leveraging the latest versions of Intel and so on?
So anything, we have custom, so we recommend the latest for performance reasons, but we have customers running on Intel V3, V4, V5. We had one customer running on the V2 gen. So performance will grow linearly. So for example, on the V5, this 2,500 SSL TPS is probably close to 3,000. And on V3, it's close to 2,000. So no, we don't need anything special, just that the modern high-performance one will have better performance. We use AES-NI instruction, which has been built in since, I think, V1 or V2 days. So anything last 10 years, not a problem.
Okay.
Yeah.
But AES-NI is prerequisite, right?
Yeah, but that's, I think, 10 years old.
I know.
Yeah.
Can you tell me, do you see a significant difference between Intel and AMD?
We haven't tried AMD, frankly, so I don't know the numbers.
Nobody is using it.
Yeah, so.
Okay.
You had a question?
Yeah, actually, still I was thinking about this architecture and active-active, especially when we have, let's say, multiple data centers and VM mobility. So, and I don't want to kill the VM. I want to move that, but let's say we are not doing source net, so when I move the VM to another data center, I want to go back from that moved data center, second data center, so I don't want to come back, so I want to avoid hair pinning, so I want to go from here. And in traditional load balancer, state is here in the first data center, not in the second one. And it was a problem anyway. So now with this one,
the same thing.
How? This one should be solving that, right? So at least the second one can tunnel the traffic, make rewrite, and send it back to first data center. Is it? So by the way, without maybe drawing this as a bit.
No, you have the service. The service engine that owns the traffic is wherever the service engine is.
Okay.
And the service engine rewrites the source address so that the traffic goes back through the same service engine. If the service engine is here and the VM happens to be there, bad luck. So don't ever do that.
That's why. Can I send the traffic from that moved location, the second location, directly?
No. No, you can't, because someone has to do the IP address rewrite on the return.
Yeah.
Someone owns the TCP session.
That's the problem. Now, can you synchronize this session information between?
It's very expensive. It's not worth doing it. So yes, we have TCP connection mirroring for certain type of workloads, but it's been used less than 0.5%.
Because most fix the network design.
No,
I want
most sessions are short-lived. Most sessions are short-lived, so people actually say, kill the session. Let it reestablish. When it reestablishes with GSLB, DNS-based GSLB, location-aware GSLB, it'll go to the new data center and start from there.
But application will time out, right?
Yeah, as I said, most applications they handle these things.
Okay. Yeah, it's
so
all
there are
web-based
there are legacy applications which don't, and so we do have connection mirroring support for that. What you just said, where session is mirrored, but as I said, it's been used less than 0.5%. It's not common. Before we go to the demo, which is next, licensing. So licensing is based on the compute capacity of service engines, number of cores, right? So 1 core, 2 cores, 10 cores, etc. That's the basic unit. And it's completely universal. It doesn't get locked into a specific hardware. The same license you can move from VMware to OpenStack to bare metal to public cloud. Okay? We have certain more optimized versions, like if you deploy in a bare metal environment, we can also cost optimized version with a socket license. And some customers want sub vCPU license, sub core license, because they're very low performance. We have a couple of 25 and 200 meg, but those are exceptions. The most common, most widely deployed model is a vCPU model. And that's because, as I showed earlier, the performance is linear with the number of cores. So if I have 10 cores, it's 10x performance, 100 cores, 100x performance. The pricing is just based on number of cores. And that's why it's not an appliance. So for example, if you buy a legacy 10 gig appliance and a separate 10 gig appliance, you don't have 20 gig capacity. You have 2 silos of 10 gig. With Avi, if you buy 20 cores, you can deploy 20 load balancers of 1 core each, or 1 load balancer of 20 cores, or anything in between. That's the beauty.
Just before we started, I was explaining to people how great you are because you have bandwidth-based license.
As well, on the short end side, yes.
No, the problem I see with the traditional appliances or your current approach is that now I have to pool all my applications onto the same pool of cores because you are charging me by cores. I can't afford to have this application 1 core, this application 1 core, this application 1 core. Which means that all of a sudden we are back in the same big bucket, and then everyone is scared of making changes because you rattled the big bucket and the water spills over.
So good question. So we do have 2 answers to that. So for when an application needs, so what you're talking about is a per app license model.
Well, I would like to have per app load balancer.
Yes, per app load balance.
Yeah.
So we do have a variation on the per core model, where if you're deploying on a per application basis, we have 1:4 ratio. So we'll actually count only 25%.
Okay.
Because, so we have a cost optimized version. If you go to a website, it's actually spelled out that by default it's a core license, but if you want to dedicate a VIP or 2 on a single service engine, we will count it at 25% license.
Okay.
To help you with that. Or if the bandwidth is low, just use the 25 meg or 200 meg license. So we have customers doing exactly that. We have one customer who is doing per app load balancing using the 1/4 math. We have one other customer doing 25 meg licenses on a very low end. So yes. So the most common deployment we have seen right now is per tenant, which means a tenant will have a few service engines, 2 to 4 service engines of 2 to 4 core each, and they put 10 to 20 apps in one line of business. That's the most common. We have cases where people are the very cutting edge with per app, and we encourage that.
So just to clarify, this license is including all the features, including the WAF, or this is an extra license?
Thank you. Single SKU, all features included, 24/7 support included. It's a subscription model.
Okay, great.
Right? Yeah, so there is no good, better, best.
I don't have to pay for
They love you to turn on the features because then you burn more cores.
Yeah.
Well, that's compute, yes. That's the compute utilization. We give you performance sizing numbers, right? So if you need, so most of our customers are deployed, are not throughput bound, by the way, they are SSL TPS bound. So we tell them, what's your performance needs? By the way, most of the appliances, traditional appliances, are 10 to 20% utilized. And so when we convert to Avi, it's immediate cost savings of 50% or more. Because you're using active-active, you don't have to be 10% utilized, it's all a pool of capacity. So customers see 50+% cost savings right off the bat, both upfront and ongoing. All right, last slide, and I won't read through that, but basically the point on this slide is it's a full-featured enterprise-grade solution. So everything you expect from a traditional ADC, the left 2 columns, layer 4, layer 7, SSL, DDoS, WAF, iRules equivalent. It's the most common question. Do you support iRules equivalent policies from F5? Yes, about 90% of those are built-in policies. Plus, we have our own scripting language. But also analytics and centralized management and multi-tenancy built in. Demo time. All right, we're doing well. So in this demo environment, I'm going to show you my setup where I have 3 environments. My controller is running on-prem in a vCenter environment with some workloads virtualized, containers and bare metal as well. I'll focus on the virtualized on-prem. We have certain workloads running in AWS, certain workloads running in Azure. all managed by the same controller. Okay, sit down.
Just to make sure you're not running the same VIPs on service engines in AWS and on premises, right?
No, but we have GSLB.
Yeah, of course, but that's a different story.
Yes, it's a different story. Yes, so same whip, typically not. Same application, typically if you want to run in two different environments, you use GSLB, Global Server Load Balancing.
Where is located?
Sorry, which?
It's located where?
The GSLB?
Yeah.
GSLB will be in both places, or one. Yeah, typically you would put an instance for DNS in each of the two locations. So I'll show you GSLB as well. So we do have certain configurations where it's running GSLB. So the first thing I'll do is let me actually sign out and sign back in. And we use SAML-based SSO to get in. So let me get in. I'm using my Avi Networks SSO to get in. Okay, and when I get into my tenancy. So I got logged into demo tenant, and I have access to a few other tenants. There are about 10 plus tenants in this environment. I have access to about 5 or 6 of them. Okay, so I got logged into demo tenant, and as a user, I see what? My applications. I don't see load balancers. Because at the end of the day, you deploy load balancer, why? For performance, availability, and security of your applications. So this is an application dashboard, not a load balancer dashboard. I have applications in my tenancy running in multiple clouds. I have some applications running on-prem. I have some applications running in AWS. I have applications running in Azure. So all the multi-cloud applications in my tenant in a single dashboard. Okay, that's one thing. Second, each application has a color-coded health score, right? So for example, this application has a health score of 59, which is a measure, which is a combination of performance of the application, 79 out of 100, which measures throughput, latency, any errors. But also it measures resource utilization, resources of both load balancer resources and backend application resources. How do we get that? From vCenter or AWS. We call the APIs for the backend pool members and see what the health is. Any anomalous behavior and any security issues. Security issues could be a WAF attack, a DDoS attack, SSL certificate that's about to expire, or a weak cipher that you've configured. So very application-centric view.
But you can dig deeper into those scores?
I'll get there, yes, absolutely. Think of this as a 100,000-foot view. I'll go to 10,000-foot view and needle in the haystack analysis. A slightly different view, this is the first time you will see infrastructure. So in this case, the same whip that we saw earlier, it's running on 2 load balancers in active-active fashion on-prem. It has 3 pools of servers, URL-based content switching. The backend servers are all running in VLAN 100. This is on-prem. And the last column is the set of backend instances and their health. So you see most of them are green. One of them is red. Why is it red? It's marked red by, it's marked down by the health monitor. And the issue is ARP is unresolved. So it's a networking issue in the backend. This one is gray. Why? Because it's been disabled by the user. So basically this view gives you a health of the application, the view of the application as a function of not just the load balancer, but also the backend instances. Right? And this is available in any environment. If you were doing in AWS, same thing. Running in active-active fashion in 2 availability zones, and in this case, the health is great.
Just a quick question. Can you simply take a check which health monitor was now showing that this instance is down?
Yes, so this one, right? It says the system HTTP is the name of the health monitor.
Okay, and you have, I guess, multiple health monitors so that I get, okay, this is maybe, what is the reason that this server is not responding?
Correct, yeah, it's an ARP. In this case, it's so this tells you which health monitor, and this gives the error code.
Okay.
Right.
In, let's say, AWS environment, if I spin up a VM with a particular tag, can you automatically get that information and add it to the pool?
Yes, okay. Absolutely. We can do based on auto-scaling group or based on tags. That's right.
For the first one on the list, that's gray, you said it was disabled.
Yes, by the user it says. So
that could be tracked in a log?
Oh yeah, yes, I'll go to get there in a minute. Absolutely. So now I'll go 2 sets of demos. One is provisioning. Let's say you are a network admin or an app admin, and with a self-service that a lot of our customers do, without opening up a ticket, I want to create my own load balancing whip and troubleshoot it. So that's one set of demo I'll do. Second set of is day 2 operations where it's up and running, I'm running traffic, I want to do some performance analysis, some troubleshooting capabilities. Okay, we'll talk about that. So let's do the first piece of the demo, which is web creation. So there are 2 options, basic and advanced. Start with the basic and I'll go to the advanced next. The first question it asks is, which cloud? Because this controller is managing multiple clouds or workloads in multiple clouds. And so that, I just have opened another tab here where I have, okay, let's just get rid of that, go here, and let's duplicate the tab. And I want to go to a different tenant and show you the concept of cloud connector. We go to the admin tenant and go to infrastructure. And in infrastructure, let me go to cloud. So this is, on day 0, I've configured the cloud connectors, the cloud, how does the Avi controller talk to different clouds? So for example, in a vCenter environment, so it's a vCenter type environment. These are all the built-in cloud connector options. I go to infrastructure, you will see I've given it vCenter credentials. I've given IPAM and DNS. We can support our own or integrate with a third party. And is there any SDN in the environment? Is it Cisco APIC or VMware NSX? We have configured vCenter, data center environment, and a bunch of other configurations. The same thing, if I were to go to AWS, we've configured the region, the access credentials, and we automatically pull the list of VPCs, and we have picked the right VPC we want to use with the availability zone, as well as the DNS Route 53 and so on. These are one-time configurations, day 0 configuration. This is how Avi controller talks to these environments to be able to spin up the VMs and do all the plumbing. Okay. So now, when I go here and I say, let me spin up this in an on-prem vCenter environment. Okay, so this is one screen. By the way, whatever I'm doing here through UI is actually calling a set of APIs under the hood. And there's also a macro API where a single API you can create a whip. Most of our customers do this automated through Ansible or Terraform, included as part of their CI/CD pipelines with Jenkins and so on. That's the most common deployment model.
So calling the means that the web front end is basically calling the API.
That's right.
And doing everything. So if I didn't want to use the web front end, I could do
of course.
scripting with the API.
Yes. So in fact, if you're familiar with so API documentation is built into the product. You're familiar with Swagger? That's a form of API documentation that's built into the controller, where every object is available here. So for example, a virtual service object, what are the CLIs, examples, all the APIs, let's say get on this object, common sample JSON blob, everything is right here. So you can try it out.
So the strategy is to implement everything in the API first and then add it to the web front end?
That's right. A subset of that is get added to the web front end. API is 100% coverage. That's the only way. Web is about 80 to 90% coverage. CLI is close to 100% coverage.
Well, as long as the API has everything.
Exactly.
Yeah.
Exactly. And we have Ansible towers and part of Ansible core. All right. So let's go ahead and name this guy. So I'm going to call it Avi TFDX app, just a name. It auto allocates the VIP. Just select the VLAN. It auto allocates or rather, it publishes to the DNS. And let's configure SSL, TLS certificate. We can do both EC and RSA on the same VIP. And then you add backend servers. Now, backend servers you can add by IP, by DNS, or in this case, you can also do discovery. So my controller talks to vCenter, gets a list of all the VLANs or the port groups that are on that vCenter. I know my backend server is running on VLAN 100. I select that. I see a list of all the VMs in my environment in that VLAN 100. Okay. This is all Avi controller talking to vCenter server through the APIs. I search for the web servers that I want to load balance. I want just 3 of those, add, and they got added with the appropriate IP address, and I say save. That's it. Automatically, what happened was a backend pool was created, pool object, the servers got added, and the controller first did an inventory analysis saying, do I have enough capacity? If not, let me spin up another VM. Then on that service engine VM, is the backend VLAN connectivity, the vCenter connectivity is there or not, the front-end traffic connectivity? If not, program that. Download the policy. It picked one of the existing service engines, this one. It downloaded the policy, got the IP address, published to DNS, and is ready to receive traffic. Okay, 30 seconds or less. Compare that to with the legacy appliances, you do manual spreadsheet-based capacity planning, spin up a VM, manually configure it, and then go, right? So typically it takes hours. This is seconds. Now, to run traffic.
What is the standard health check that you implemented with this?
Great question. Let's do that. So that a pool object got created. So on that one, let me show you. So on this pool, the standard health check that we did was a passive health monitor. You can do active health monitors. You can do system HTTP. System HTTP was already there. You can do HTTP, HTTPS. You can do ping. You can do whatever you want. The custom one.
Active means he makes a real web request.
This is
that.
Yes.
Okay.
So there's both active and a passive. Passive means as part of the traffic, it's doing the health check.
I can even define the request that it should do.
Yes,
okay.
and also the response saying 200 and X. So yes, absolutely. Oh yeah, it's a full-featured load balancer. You can. It picked up least connections because that was a default template, but you can pick whatever load balancing algorithm you want. You can put persistency, etc. Right. Now, discard the changes. So let's run some traffic, right? So we'll go ahead and run the traffic. And let's go ahead and it's complain about the TLS profile because the name doesn't match. So we'll ignore that. And that's your traffic. Okay. So go back to the dashboard and let's see the traffic in action. So here, basically the idea is right there. I logged into VPN. Because it's a local DNS, and so it tells me that this is my source IP on my laptop for my request. I'm on my Mac with a Chrome browser with TLS 1.2 at 11:44 a.m. Because we 15 minutes ago. It took 169 milliseconds to go from my laptop to my load balancer that's running in my Santa Clara lab. This was the VIP IP and port. This was the snatted IP and port. It took 1 millisecond to go to the server. It picked up server number 3 from the 3 that we added. This was the URI that was looking for. It took 96 milliseconds for the application to respond and less than a millisecond to go back. Overall transaction latency was 266 milliseconds. We do this for every transaction. So imagine the power of automation and self-service where somebody configures a VIP, runs the traffic, troubleshoots it. Right? That's that easy. Now you will say, well, what about advanced policies, right?
Yeah, the web part.
Exactly. We'll do all that. So let's add a security policy, and let's say you can do network level security, allow, deny, rate limit. You can do HTTP level security. Let's do that, and let's call it a PHP rule that says you can add a match on anything. You can add a match on IP. You can add on a protocol, on query, on the path, on the header. Let's say the path ends with PHP. I want to close the connection. Okay, that's a rule. Okay, you can do request rewrites, response rewrites. You can do all of that. But let's do a simple rule first. Okay, so that gets saved. Let's go back here and let's just say admin.php. Just a simple request. Okay. Okay, and then let's do that one more time. And then go here. Where is it? Right here. And search for my logs. Right there. You see? It generated a 470 response, which is Avi closed the connection. And why? Because it matched the rule called the PHP rule that we just created. So you create a security policy or a WAF policy, you can see it in action. Right? Let's go to WAF now.
Yeah, I have another question for the WAF. Yeah, so often it's really a hard time to develop these policies. Yeah, because the application owners maybe don't even know what their application is doing.
That's right.
Yeah,
Yes.
and the guys that needs to secure that needs that input. You have somehow a learning.
Yes. So learning is in a short-term roadmap. It's coming, but we still have a lot of visibility that tells you what's going on. So most common deployment model is when WAF gets deployed, typically they deploy in the detection mode for the first week, 2 weeks, whatever, until they're baselining the performance. And during the detection mode, we'll tell you things like, what are the common attacks we're discovering? right? So, and then based on that, you can say, no, this is legitimate, this is not legitimate. So most customers start with the default profile of WAF, with the OWASP top 10 protection, and in a detection mode. And then we give you this analytics saying, what are the common groups, CRS groups that are hitting? What are the common rules that are getting hitting? What are the common IP addresses coming from? And if these are legitimate, then you can say create exceptions. Okay. And then you go put it in enforcement mode.
And do you have also some prepared profiles?
Yes,
for
exactly.
Common web apps?
That's exactly right. That's exactly right. So for example, in this case, it'll tell you this traffic came from Mexico on somebody running on iPhone, and multiple WAF rules were triggered, and you can say, no, this is legitimate, allow it. And it tells you exactly, this was a SQL injection attack, this was MySQL in this case, and another SQL injection attack. There's also some anomalous behavior that we saw, and then we also saw some correlation. So it tells you all the attacks that we flagged, and you can say, oh, this is legitimate traffic, just add the exception, boom, add the exception at the IP level or a subnet level or a URL level, and you're gold.
And I saw just the Mexico flag. Do you can also geo-based blocking so that I say Switzerland, that sounds unsecure.
Yes.
I don't want anybody from Switzerland.
Yes, you can even say if it's coming from Ivan's IP address, then yes. Yeah, you can do full geo-based blocking as well. Yeah, exactly.
What about IPv6?
Yes. IPv6 complete support. Yes, that's right. Of course.
Well.
And the last thing I'll show you is on that same VIP, which has been running for some time. When I go to the analytics tab, of course we show you throughput and connections and so on. But the default tab is end-to-end timing dashboard, end-to-end latency, right? Without any agents. Because as a proxy, you see all the traffic with the TCP timestamp information. And then you can say last 6 hours or yesterday or last week, what was the latency on the WAN? What was the latency on the local network? What's the application latency? And what's the latency on the wire between the first and the last byte? And so this is very useful because if you're network admins, you get blamed for all performance issues, right? It's always the network, right? So here, you can see, for example, this spike, the yellow band, which is the application latency that has shot up. So in this case, it's not the network. The application latency was in 30 milliseconds range. Now it's gone to 70 millisecond range, or even in this case, 100 milliseconds. So clearly, I mean, yesterday, 5 o'clock, something was wrong. What do you need? Can you fix it? It says, okay, go when it happens again, take a TCP dump, take logs from here, here, and here, and refile the ticket, right? You don't need to do that here. You can actually go back in time and see exactly what was happening at 2 hours ago or yesterday. What was the issue? Was it an application issue or a network issue? So this is still a 10,000-foot view. It just tells you whether it's a network issue or an application issue. You can actually go further down and go to the logs here, and I can do that analysis and say, for example, I showed you earlier already that individual transactions are captured, but I can also find out what are the latency profiles. So I can go here, actually right here, and say, give me a histogram of all the latency profiles. So it tells you, for example, this is the end-to-end latency histogram of my clients. And about 90% are less than 300 milliseconds. But there are some that very high latency. So you can say, okay, let me figure out who has more than 800 milliseconds of latency. So filter those logs, and then you can see, is it coming from a specific client? No. Is it coming from a specific location? Yeah, almost 99% is coming from India, right? So you can do this level of analysis saying, oh, somebody's complaining, it's all tied to our India location, it's a WAN issue. In fact, you can see that. If I filter on here, you can see what part of the latency is high, and usually the green band, which is the WAN latency, which is extremely high.
One question, can you also forward alarms that were flagged by your WAF to a CM, or
yes,
must be pulled out of the API, or you have also connected to push out something?
Both.
Both.
Yes.
Great.
So I'll show you that in just a minute. So that's the next piece of demo. Before I do that, though, our application owners love this screen as well, because if they are developing the next version of the application, they need to know what to optimize on. What are the different browsers coming in? What are the different devices coming in, right? Or if you're a security admin, You like it because you know what the TLS profiles of your traffic is. And let's say we had a customer who says, I want to deprecate TLS 1.0. Okay? All I have to do is click on this and filter the logs, and then it can say which client IPs this is coming from. And basically, if this is an internal application, just say, hey guys, please update your thing. Or you can do a local response on Avi saying, if the TLS profile is TLS 1.0, generate an error page saying, sorry, not supported. Right. So it's extremely easy. Just think of this as a Google-like or a Splunk-like search engine for your application logs. Right. You can do lots of other things, like I'm familiar with the 404 error. So for example, if you're, it's a missing page error, right? So right here, I see a 404, and I can filter my log saying which URLs are generating 404. It's right there. It tells you about half a dozen or so, but about 90% is just one URL. Let's see which backend server this is missing on. It's missing on only one server. So again, a lot of application level analytics and troubleshooting and end-to-end. Okay, operations. You asked about alarms, and somebody asked about audit logs. You want to ask about traffic capture? Yes, and yes. So here on the event section, we have the full config audit trail about who did what. In fact, we superimpose that on the log screen as well. So let me show you that here.
Can you tie that into Splunk?
Oh yes, we have a Splunk app actually. You go to Splunk store and download Avi app. Yes, we have AppD integration, Tetration integration, Grafana integration, and we can also stream out logs. So you can pull or push, to your point, for the logs. So here, for example, on this one, if I go yesterday, right here, and if I go yesterday, I think I made some change. We capture all the events and configs that were done on an application. So it doesn't look like here. Let's go to past week. And it tells you actually who did what. So that's what I'm trying to show you here. I think it'll take a few minutes here. So here, for example, this one, this was the config audit, and it tells you who did that. So this was done by Ashish at avinetworks.com. So the VIP that we created a security policy, right? That's right here. It was a config update right at the audit trail. Somebody asked about the alerts. So you can actually generate custom alerts like this on any metric. So you can say, for example, create an alert on an event. Event could be something went up or something went down, or to your point, a metric on a virtual service, and says the WAF score went above a certain threshold. I want to do something, and that something can be a custom alert, which is it can send an email, it can send a syslog, it can send an SNMP trap, or it can also do a custom Python script. Right? So we have a fully programmable control plane as well, where based on hundreds of telemetry data, you can say, if this happens, execute this script, which could, again, call other APIs. So it's a fully programmable setup. And finally, we also have the ability to do traffic capture at the virtual service level. So if in earlier case, remember we talked about scaled out VIPs. So if your VIP is on multiple service engines, we can automatically do traffic captures on all the service engines, interleave the front and the back traffic appropriately, in and go. So you can just.
Can you do this also on event based?
Yes.
So if this happens,
then start a traffic capture. Yeah, it's actually very easy. Based on a metric, you say trigger this action. The action is run a script that calls Avi APIs that says traffic capture. So absolutely.
Great.
Yeah. It's a fully programmable thing, right? So
how are you doing the traffic capture? Are you doing that with your own code, or are you?
Yeah. You know, we own the TCP/IP stack, right? So we capture the packets, and you download the file.
Okay. What formats do you support?
Wireshark, basically. Just download the Wireshark. So here you can say all traffic, or you can filter it by certain source IP, destination IP, subnet mask. So you can also limit what you want to capture. You can do it. I want 100 packets or 1,000 packets, or do it for 5 minutes, whatever you want. And you can say how much size of the data packets you want to capture, limit the amount of data captured, and you want to capture data traffic only or health monitor also, right? So to keep it simple, right? So it's very powerful.
Okay. So the format is, I'm just asking, PCAP or PCAP-NG? Because
I believe it's
PCAP-NG
PCAP, yeah.
Yeah, okay. Because PCAP-NG may be interesting for you because you can store additional comments, stuff like that, into the PCAP file.
Okay,
So
I'll
you could
find out.
annotate stuff like this was on this.
I see. Okay. Yeah, I don't know. I'll find out
Yeah,
if
that
PCAP
would be a good improvement, I think.
Yep. All right. That was we're almost out of time, so that's pretty much the end of the demo. I'm happy to continue more. Last slide on this one. So typically where Avi gets deployed is 3 use cases and 3 buckets of use cases, I should say. On-prem, on-premises, where we replace legacy vendors, hardware, software vendors, virtual appliances. And the benefit the customers get is ease of deployment, centralized management, full automation, easy analytics, and significant cost savings. In fact, consistently we are getting from our customers that the initiative they're driving is automation. Some with SDN, some without SDN, but it's all around network automation, infrastructure automation, and this fits right in there. Right? Public cloud, and you might wonder why customers deploy us in public cloud. Why don't they use ELB or application gateway? 3 reasons. Enterprise-grade features, multi-cloud consistency, cloud-native automation. What I mean by that is you don't have to choose between features of appliances and automation of the cloud-native tools. You get both with Avi, plus the analytics, and it's not more expensive. It's about the same price as you pay ELB or App Gateway. So it's a win-win. Because most customers are multi-cloud today. Or when I say multi-cloud, not same applications running multiple clouds, but different applications, different cloud, and they want the operational consistency. They want automation consistency. And elastic service mesh. We have large banks running in production with Kubernetes and OpenShift for the last 2+ years. Why? Because it's a full-featured load balancer, both north, south, and east, west. And we are also getting Istio integration in the next couple of months. Okay, I think that's it. Any questions? Yes, sir.
Comment.
Comments?
Yeah, actually, I see that especially good automation and orchestration you are doing here. Maybe not that first slide, decoupling the control plane from the data plane, but that orchestration gives the power, yeah.
Yep, yeah, absolutely. Thank you. Any other